Today's LB idea is that quantum's impact reaches beyond the scientific community, presenting valuable opportunities for businesses, investors, and innovators. Our guest today is Scott Sternberg, Executive Director of the University of Colorado Boulder CUbit Quantum Initiative. With an extensive background in leadership and business development, Scott is committed to encouraging the long-term sustainable growth of the initiative and Colorado's quantum economy as a whole. Thank you so much for joining us today, Scott.
Pleasure to be here, Maria.
Great. Well, let's jump into these questions. We've got so much to talk about. A lot of people have heard the word quantum, but may not know what it means. Can you explain what quantum information science and technology is in simple terms?
I can, and I have to say I get that question a lot lately, so I leave it to the audience to see how well I answer that, because in my opinion, it's one of the more fundamental things that we're challenged with, and that is literally explaining what we're doing, right? And so the word quantum actually relates to the physics or the mathematics that occurs at the very, very small scale. That is to say, at the scale of atoms or even at subatomic levels. And when you start to observe what is happening in terms of the interaction between light and atoms or atoms with other atoms, you start to see a very different behavior than what we experience in what we call the macroscopic world. So as we throw a ball and it follows an arc and someone catches it on the other end, we're very in tune with exactly the physics that dominates that trajectory. But when you go into the atomic level and the subatomic level, things behave much, much differently. So about 100 years ago, this observation of this new world was starting to come into view, and there was a whole new mathematics around what we call quantum mechanics that was created. And so this year in 2025, we're actually celebrating the 100th year of that particular discovery and the beginning of this, let's say, new way of explaining the physical world at the atomic level. And I would say over the past 100 years, our engineering prowess has caught up to the theoretical physics, and we're able to now build devices like a laser, like a digital camera, and like some of the new quantum computers and other wonderful sensing technology that is now driving sort of this new popular word quantum in our standard conversations these days. So yeah, it's a wonderful time to be here 100 years after the initial discovery.
It's kind of incredible to think that it really all started 100 years ago. You know, today it seems like we're hearing so much more about quantum. And I'm curious if you could just talk about why is it now? What's the momentum in the past couple of years?
Mm-hmm. Well, there's a couple of physical principles that have literally existed for that 100 years in the theoretical space. It's only really been within the past decade where we've been able to engineer products and technology to be able to capture and control this quantum phenomenon. And so by confining single atoms and interacting with other atoms that are in that same confined state, we start to be able to unleash this incredible power that nature itself has at its core. That can be manifested in new quantum computers, which is typically what's driving a lot of the interest in the news media these days. By engaging this science at these subatomic levels, you can envision computers that are enormously more powerful than the ones that we have today. And that allows us to either potentially solve problems that are literally impossible to solve with traditional computers, or to be able to solve larger problems a lot faster. And so the impacts on society are projected to be enormous once we engineer these products that create this next generation of computing power. And that's really why we're hearing so much more and more about quantum in the news media and in our standards conversations, because the impact on society is just going to be enormous, or is projected to be enormous, both financially and from a societal and cultural aspect. So we're really at the precipice of a new generation of technology.
So is there anything that anybody in the world today could look at around them and say, oh, that has quantum technology driving it?
Yeah.
Are we at the point where it's kind of in our world and maybe we're not even aware of it?
Well, there's a couple of things. I'd like to tell the story, where were you when you first saw the first laser, right? Where were you when you saw that laser light for the first time? Laser light is inherently a quantum phenomenon. And so many years ago, we talked about the laser in the halls of the physics buildings and in the engineering buildings, and only a handful of people knew that actually the word laser is an acronym for something that very accurately describes what's happening at the quantum level. But today, I think you could go into a second or third grade classroom and everyone could describe what a laser is, what the nature of light, why it's unique, why it's different. And so that is a perfect example of how a quantum phenomenon that was developed or was envisioned in this 100-year time frame that has now been engineered into a product that has impacted society tremendously. And so things like the laser, things like the digital camera, where were you when you first had your first digital camera? And how interesting was that and how difficult was that to use potentially compared to the cell phones that we carry around in our pocket today? So literally, these are quantum devices at their core, and we're just now exploiting yet another quantum phenomenon to enable quantum computing, quantum sensing, and then potentially highly encrypted quantum networks. And so we're really excited because quantum's around us. You may not realize it, but it's this recent awareness that the impacts to society from quantum computing has really brought this to the forefront of our conversation.
Great. Well, I know that the CUbit Quantum Initiative has a lot of different facets, but at a high level, what is the initiative hoping to achieve and what are its tactics?
Yeah, I think to answer that question, you have to realize the history or the legacy of quantum research and fundamental discovery here at CU Boulder. In 1962, we formed an institute, which we call GILA, which is a joint institute between the National Institute of Standards and Technology and CU Physics. And this was an opportunity for academicians as well as government employees and researchers to come together and to work on some extraordinarily challenging problems. And so, over that half century of, let's say, investment and engaging research and development, we have established what is an internationally recognized center for optics, photonics, atomic, molecular, and optical physics, and then, of course, quantum science. This is best evidenced by the fact that we have 4 Nobel laureates that have passed through the institution, and has really put Colorado at the epicenter of quantum science. So as we have grown, the technology and the interest in quantum science has gone literally across campus. So we've gone into our engineering college to be able to engineer quantum devices. We, of course, have moved into the business school to understand the business behind a lot of the optics and photonics companies that have been spawned out of the university and more generally the impact on society. And of course, as we're very strong in aerospace, climate science, and now growing interest in national security, quantum sciences will be enabling those disciplines as well. So the CUbit Quantum Initiative, given this backdrop and given the scale of what we're doing here on campus, is really charged with coordinating, convening, and catalyzing all of those activities together. So if you think about it as a horizontal position where I can walk seamlessly across campus into almost every college or every department and talk about how quantum potentially can be infused into the curriculum, infused into the research agenda, or actually motivating products to come out of the university, it is exactly that kind of behavior that we're trying to spawn. So it's an exciting job. It's a big job, I would say, and especially in a time where quantum is accelerating in its adoption and interest level.
So you're talking about CUbit across the campus. Could you talk about why this is important for the whole state of Colorado and for the region?
Yeah, well, because of our state presence and because of the legacy that CU Boulder has created over this half century or more, we've seen enormous opportunity for companies to either be spawned out of the university, and not just out of CU Boulder, but out of the other research institutions that we have here in Colorado, and have created a coalition and sort of a concentration of both quantum companies and quantum enabling companies. Those are companies that might make a laser that is so unique that it is applied for quantum technology, or an optic or a software algorithm or what have you. So as we sit here today, we have arguably the largest density of quantum companies per capita in the world as a result of these companies translating out of the university or locating here because they want to be close to the technology and to the scientists. And we have been recognized by the Economic Development Administration through a Technology and Innovation Hub grant that was submitted by an organization called Elevate Quantum as the tech hub for quantum science in the nation. And so it's this long history that we have investing in fundamental science, growing into engineering, growing into the interdisciplinary spaces in the other colleges and departments that has spawned these companies to come out that have kind of taken traction here in the region. And that was quite frankly, the core of our argument as to why Colorado needs to be at the center of this technology and innovation hub. So we're really excited because that represents this generation of the lab to market transition that will start to create products that will impact society and create economic gain for the region as well.
So, shifting gears a little bit, I'd love to learn more about your background and how you ended up in this really unique role at CU Boulder.
Well, I kind of jokingly call myself, or I had called myself a recovering physicist. So I have a master's degree in atomic and molecular and optical physics from Colorado State University. So I'm a Colorado regional person, educated here in the state. I chose not to go into an academic career, but more so into the private sector. And so I first joined a company that was in digital imaging and was there for a little over a decade, and then spent, I would say, the bulk of my career working at an international company around weather and climate science. And of course, here in the Colorado, and especially in CU Boulder and within the Boulder surrounding region, climate and sustainability research and technology development is also an area of expertise. And so it's been great to sort of circulate through my career through the lens of science and physics, and specifically mostly optical physics, but in the context of developing products and solutions for economic gain. I would say, lastly, I joined the Boulder Chamber of Commerce right at the height of the pandemic. Some people said, why are you getting into economic development when there is no economic development to be done during
It was
COVID?
a tough time.
It was a tough time. But I argued that's exactly when folks needed to come in and start assisting and helping businesses, because that's actually when they needed it the most. And so all of that experience, I think, has been wonderful to bring into this role, because in any given day, we're talking about science, we're talking about engineering, we're talking about government policy associated to climate and our quantum initiatives. And we're also talking to organizations and industries that are trying to grow and grow out of the university and potentially create new companies and solutions for society. So all of that taken in concert, it sort of is a portfolio of experience that I use every day, and it's important to do so.
Incredible. I mean, that's a perfect bridge, right, from the Chamber of Commerce into CUbit, because CUbit's really focused, as you were saying, with partnering with business and industry right now. So I'm wondering if you could share with us, what are the opportunities for businesses in this landscape to partner through CUbit or with CU Boulder, or maybe just more broadly in the region?
Well, there's a couple of areas. I mean, we have a very strong sponsored research program that allows organizations at any scale to identify researchers on campus that might have shared interest in their science with perhaps the product roadmaps that the companies are trying to deliver on. And so that's usually the first foray into industry academia engagement, where a company says, ooh, we need to break through a barrier, and there's a faculty member or a researcher that is doing exactly the same kind of work, and we'll collaborate and sponsor the research going forward. And so that's a pretty typical engagement path that a lot of industry organizations take. We're seeing more and more now that in the context of deep tech, as we call it, of which quantum certainly falls into that category, that a lot of the technology translation organizations, tech transfer organizations, as we call them, in our case, CU Venture Partners, are extraordinarily focused on identifying technologies that could potentially create either products or would serve the basis of company creation out of the university. And so that brings in venture capitalists, investors, perhaps large companies that want to identify those small companies early on and invest or partner with those. And so our technology translation exercises through the CU Venture Partners program has been a huge attractor for a lot of companies to get engaged with the university. And I would just say, lastly, over the half century that we've been doing this, we literally have graduated what are now the thought leaders across the quantum industry worldwide. And so every company that might have an interest in growing their portfolio or somehow moving into a different marketplace that is quantum related is looking for workforce. And they're looking for qualified people that understand what quantum is, understand how to engineer quantum, understand just how to talk quantum, right, at certain levels. Because as this economy is going to grow, we're going to need PhD scientists. We're going to need engineers. We're also going to need folks in finance, in business management, in leadership, in media and communications that round out the foundation of the workforce that is required to deliver these products. And so it's great to be at this nascent stage where, yes, we're sort of at the science pinnacle, if you will, of quantum technology, but we're now quickly going to move into what is a traditional large-scale business environment, which requires all types of business interaction across all of the different disciplines to engage in this conversation.
So really quantum no longer just for scientists. What I'm hearing is this becomes a field that requires people from all walks of life to work on it, care about it, be passionate about it.
It definitely is. If you think about and you look at some of the reports that are coming from places like Gartner and McKinsey and some of the traditional market forecasts that come out for different technology spaces, they're absolutely astounding in terms of the projected impact that this is going to have. So indeed, there's huge opportunity for people to get engaged. I also think there's a huge opportunity for folks that are working in adjacent fields to translate their skill sets into the quantum industry and bring the skills that they have, again, in traditional disciplines that the business community relies on: marketing, relations, business leadership, business management, accounting, finance. All of these skills are going to be needed to transition into the quantum community. And so it's really an interesting time. It's a whole new space. And to be quantum aware first, that is to say, what is quantum? And then to be able to talk a little bit, not so much about the science, but about the potential implications that it will have in healthcare, in medicine, in telemetry and timing and GPS challenged areas, and all of the areas that we're talking about. It is an exciting opportunity for people to reinvent themselves, so to speak, in a new discipline, albeit with the skills that they've learned up to that point in their career.
So with your work through the Chamber of Commerce and through CUbit, what do you wish the business community understood better about quantum?
I would say, I'm just going to quote from our quantum strategy here on campus: the future of quantum is here. It's here and now. It's happening. There are quantum sensors that are making a difference today. And it's here on the CU Boulder campus. It's here in Colorado. It's here in the Rocky Mountain region. And so I really stress that people need to just sort of read a little bit more about it. Don't just flip through when the word quantum comes on your newsfeed. Maybe stop a little bit and educate yourself a little bit more about what we're trying to do here, because it's really going to take a large effort to not just create Colorado as an epicenter, but really to put the United States in a global position where we are leading this quantum revolution. And that's what the federal government has designated through our Tech Hub designation, as well as some federal initiatives that are promoting the science. And we're in a unique position to grow our economy accordingly. So it's a wonderful time to be here and craft the future of quantum.
Yeah. Are there specific projected economic impacts that you can share?
Yes. Well, I'm going to say yes and no. Read some of these market projections that the groups project. They're just astounding. They're huge hockey sticks, right? So we're here, and then all of a sudden we're way, way up there, in the near future. And there's so much variance in terms of what that projection is in an absolute sense. And then there's even more contention around when is that actually going to be achieved. And so you have to sort of take that with a bit of grain of salt, because there's so much variability. But nonetheless, everyone agrees that the economic impact for quantum technology is going to be large and far-reaching. Bringing it a little closer to home, I can say we have about 3,000 people working in the quantum community here in the state of Colorado, mostly in the Boulder, Denver metro region. And our initiative in the next 5 years is to grow that up to 10,000 employees. And so that has a lot of implications in the sense that we have to grow the companies that create the demand for those employees. To grow the companies, we have to have an active community, both promoting that, providing the workforce development content through curricular development and what have you, as well as translating that science out for new ideas to generate new products in the quantum community. So that number of going from 3,000 and tripling, it's, if you will, more so up to 10,000, has not just an employee implication, it has implications across the entire ecosystem when you think about what it takes to do that. And so that's sort of our guiding star, and that's what we're trying to achieve in that relatively short period of time.
Well, how about students? We have 38,000 or so students on the CU Boulder campus. How can students prepare for the world of quantum?
It's a great question. Again, I think here CU Boulder is really leading the charge in terms of providing experiential opportunities for students, regardless of whether they're in the STEM fields or not. We have a program that we're very proud of called the Quantum Scholars Program. And that is an extracurricular stipend-based program where students can get exposure to individuals, companies, or at least the conversation surrounding quantum if they're interested. More so embedded in some of the traditional physics and engineering course loads, we have a program called the Quantum Forge. And that program is expressly designed to have industry sit next to our students, bring a problem, possibly bringing instrumentation to the campus, and over the period of a year, really solving some of the problems that industry has in a capstone environment for the students. And so in that context, it's really great to see that we're bringing resources on campus for students across all disciplines to learn a little bit more about quantum. And then, of course, listening to podcasts such as this. If you have the interest in the business community and you say, hey, what's this quantum industry all about? There are resources like this and others that are trying to keep abreast of all of the different movements in the industry that we're seeing in the quantum community.
That's great. And in addition to podcasts, are there other resources you recommend, a certain book or website, blog that folks might look to learn more?
Well, I would be remiss if I didn't say subscribe to the CUbit newsletter here on the CU Boulder campus. That can be found at CUBoulder/CUbit, spelled CUbit. And so we do publish a newsletter every month that is mostly focused on CU Boulder quantum activities, but also looks at the broader community of what's going on. There's a great LinkedIn newsfeed called the Quantum Insider that traditionally looks more broadly across the globe around some of the major announcements that are happening specifically around quantum computing companies and other kind of policy related issues that are happening certainly here in the country, but also in the context of this International Year of Quantum that UNESCO has designated. And so that's a wonderful opportunity to take advantage of all of the material that has been sort of amplified as a result of UNESCO designating 2025 as the International Year of Quantum.
Well, thank you so much for your time today, Scott. It was great celebrating 100 years of quantum with you. I think people are going to come away from this conversation with a much better understanding of quantum, and I know I learned a lot. So thank you.
Pleasure to be here.
Thank you again for listening to Leeds Business Insights. Make sure you're one of the first to hear every episode by subscribing to the show wherever you get your podcasts. Leeds Business Insights podcast is a production of the Leeds School of Business and is produced by University FM. We'll see you next time.